Welcome to Geography. I'm Mr. Ortega. Let's explore our amazing world together this time.
The Earth is a three-dimensional sphere spanning nearly 25,000 miles in circumference. Early navigation required shrinking that massive volume down until it could fit onto a single sheet of parchment. This creates a direct conflict in geometry. We live on a globe, but our tools for calculating travel, like the paper on this desk, are perfectly flat. In the 19th century, Carl Friedrich Gauss proved the physical limit of this task with his theorema egregium. The math shows that you cannot unroll the Earth onto a flat surface without the edges stretching and tearing. Because of this distortion, every map is a mathematical translation. To read one, you have to understand the specific set of rules used to stitch those tears back together. Cartographers built this system layer by layer. They developed engineering standards to bridge the gap between the 3D planet and the paper in your hands. A map is not just a drawing, it is a surrogate for reality. It allows us to calculate distances and directions across the world without having to step foot into the unknown first. To make a map functional, we have to start with a single fixed point of reference. Before we can move, we have to know which way we are facing. This is the role of the compass rose, or rosa de los vientos. It is the tool that aligns the paper with the Earth's invisible magnetic fields. The compass rose takes the 360 degrees of the horizon and segments them into 32 headings. Each one provides a fixed line of travel across a landscape that would otherwise have no markers. This orientation provides a critical anchor. It ensures the map is locked to the physical poles of the planet, preventing it from becoming a meaningless sketch. Once direction is established, we face the problem of scale. We have to compress thousands of miles of terrain onto a surface only a few inches wide. We solve this with nominal scale. This is the mathematical ratio between a reduced model, a generative globe, and the Earth's actual size. This ratio lets us measure 1 centimeter on paper and know it represents 15,000 centimeters, or 150 meters, of physical ground. Scale is a tool of spatial compression. It allows the human mind to grasp the distance between two cities as easily as the distance between 2 points on a desk. But knowing direction and distance only works if you have an absolute starting point. Latitude provides the first half of this address. It uses sexagesimal degrees to measure how far north or south a point is from the equator. Longitude measures distance east or west from a human-designated starting line, the prime meridian. This abstract 0-degree mark is anchored to this physical location at the Royal Observatory in Greenwich. Combined, these lines wrap the globe in a grid, identifying every earthly location by their intersection. Because of this, every square inch has a unique mathematical address. We no longer rely on landmarks, we rely on coordinates. The coordinate grid transforms the map from a subjective drawing into a predictable mathematical framework. While the grid gives us location, it is still flat, but the world we actually walk through is full of vertical obstacles and varying terrain. Political maps focus on the invisible. They show the boundaries and borders created by governments, defining where one territory ends and another begins. Physical maps use color to simulate altitude. Green gradients represent low-lying plains, while browns and whites show where the crust of the Earth pushes upward into mountain ranges. This physical texture reveals the reality of the ground. It shows the traveler the mountains they must climb and the rivers they must cross. By stacking direction, scale, coordinates, and texture, we successfully translate a three-dimensional planet into a portable format. The density of information on a map like this is immense. Humans compressed the dimensions of an entire hemisphere into pocket-sized sheets. Built with rigorous geometry, these documents kept sailors on course and ensured explorers could find water in trackless deserts. The map is our system for navigating the physical world. It allows us to carry the scale of the planet in our hands, providing the logic to travel, inhabit, and understand the Earth.